I'm Kat. I'm a software engineer, and I've dabbled in a few languages over the years. I've done a fair amount of Java. I actually started out as a Java dev. Done a bit of Bash, a bit of Ruby. But predominantly, I've been a PHP developer for the last 8 years or so. So that's always been my primary language. And I still very much enjoy writing PHP. But recently, I picked up Go. By recently, I mean about 2 years ago. I picked up Go as my second main language at work. And I'm loving it. So I'm not here to tell you about how awesome Go is, because this is, after all, a PHP conference, so it wouldn't be fair. But hopefully, you'll get some idea of what Go is like from the talk. But what I'm hoping to do is to convince you that it's worth learning more than one programming language. And I want to show you how this can change you as a developer and make you better, based on my experience with switching from PHP to Go and back. So you might be thinking, what the hell, Kat? PHP solves all my problems? Well, but does it really? I mean, sometimes developers who only know one language will try to use that language for everything. And sometimes that can just cause you unnecessary grief. There might be a better tool out there that would do a better job for the task that you're about to do, but you don't know that, and you wouldn't know that if you only know one language, would you? So just as you wouldn't use a screwdriver to hammer a nail into a wall, you shouldn't necessarily try to use PHP for everything under the sun. I mean, PHP is kind of like a multi-tool, and sometimes it's famously called as the double-clawed hammer, where it can kind of do a lot of the jobs okay, but it's not ideal, and it's not for everything. And that's okay, because no language is perfect, but it doesn't mean that you should just stick to the good old hammer for everything. Sometimes it will do just fine, and sometimes it will really limit what you can do. So learning another language is just like adding a new tool to your toolbox. The more tools you have, the more jobs you can do. And you can use the right tool for the job, and you can do things the right way. And it's a really great way to learn new concepts and steal ideas from other languages, and then maybe bring them into your language. So many of the PHP tools have been inspired by things in Ruby, for example. And PHP used to be procedural, and then Java popularized object-oriented programming, and then PHP became, now OOP PHP is kind of standard. So it's worth keeping an eye on other languages, just to keep up to date with the latest trends and ideas. So let's have a look at Go, or golang, as it's formerly known. It's gaining in popularity right now. It's kind of exploded in the last year or two. But it's actually 6 years old. Unofficially, I think it's about 8 years old, or 10 even. So Go version 1 was released in 2012. Right now, Go is on 1.11.1, all the ones. And Go 2 is on the way. I'm not making that up. It's came out like 2 days ago. And Go version 2 is on the way as well, which will bring in some new stuff like generics and all sorts of new things. So Go was written by Google, by the three gentlemen here, Robert Wiesmer, Rob Pike, and Ken Thompson. So pretty big names in computer science. Go is a compiled, statically typed language. It's a little bit like C, but it has the nice things, like garbage collection, so you don't have to worry about memory management, which is great. And one of the main selling points of Go is the built-in concurrency, and we'll, of course, have a look at that in a minute. But the biggest difference between Go and PHP are, of course, the logos and the derived mascots, like it's gophers versus elephants. So they come in a lot of different shapes and sizes. Like that's a small sample here, and I also have a small sample here. This was surprising. Like the width of the gopher and the elephant are actually the same, but the gophers tend to be about 20 to 25% taller. And I think eye size is the biggest differentiator between PHP and Go. I'm just kidding. We're not going to be talking about this for the next 45 minutes. One of the biggest differences is how you run Go apps versus how you run PHP apps. So PHP is an interpreted language, so you need a web server or some kind of thing that has a PHP interpreter on it to run it. And then that interpreter will translate your PHP code into machine code on the fly as you're executing your application. Go, on the other hand, is a compiled language. And that means that you first need to compile the Go code for your chosen architecture, and then you just run it like any other binary on your system. And why is this important? Because it affects the speed. Compiled languages are generally faster than interpreted languages, and that's just for the obvious reason that you do the work of translating into machine code beforehand, before you actually get to executing your app. So you just don't need to do it at runtime. So here are some benchmarks for a simple Hello World application written in Go, Node.js, and PHP. And for comparison, there's also an Nginx serving a static hello file, just like an index.php file. So Nginx is written in C. So like C is obviously the fastest, always. So the two languages on the left, C and Go, are compiled languages. And surprise, surprise, they are the fastest. Node.js is impressively close to Go, though. It's not that far off. Vanilla PHP is about 2.5 times slower than Go. It's just got under like 2K requests per second. So these are just some benchmarks I found on the internet. They are a little bit out of date, because this is PHP 5.6 and Go 1.4. So Go is now at 1.11, PHP 7.3 is obviously on the way. So both languages have progressed a lot. Like Go's garbage collection has been massively improved. PHP's like engine has been entirely reworked. But I think the general sort of message here still stands. And that's exactly the feeling and the impression I had when I got into Go. It just felt so much faster than PHP. So PHP, it's interpreted and it's built for development speed. Go is compiled and built for runtime speed. But actually, Go compilation takes about a second at most, so it doesn't actually hinder development. So it's not like, I don't know, not going to mention any names, but it's not like Java where you like go off and make a coffee and then come back and it's still compiling. It's actually pretty fast. So let's have a look at some Go code. That's a twist on the classic Hello World program. I just got bored writing those. So we have a string. Hello is something you're looking for. And what we want to do is print me or t at random. So you can see where this is going. The syntax is obviously different to PHP. The format of Go applications is actually standard across all applications. Like, you heard that right. There's one way of formatting your Go apps, no other way. And you just have to stick to it, whether you like it or not. Obviously, some people hate it. Some people loved it from like the first time. Honestly, you just get used to it over time. And the great benefit is the amount of time you save by not having to argue about which line does the bracket go on, or tabs versus spaces. It's literally in days now, I think, I've saved. So there is a tool called GoFMT, or FMT, I think it's officially supposed to be pronounced, which automatically formats your Go code behind the scenes, so you don't even need to worry about it. Like, every single ID under the sun is going to have it just on save, and it will just do it for you behind the scenes. You don't have to worry about it. And obviously, the great benefit is that if you're reading somebody else's Go code, your eyes are used to it, because there's only one way to format it. So that's the first thing that you might notice. So we need to declare our package at the top. It's a little bit like namespaces in PHP or modules in Ruby. And then we need to declare what libraries we're going to use. And don't worry, you don't have to type this in by hand. There is another Go tool called Go Imports, which will do this for you as well. So you don't have to actually work out what you're using. It will just do that list as you go along. And then we have our main function. Every Go program needs to have a main function. You might have noticed that there is no public or private in front of it, because Go has a simple convention that anything starting with uppercase is public, and everything starting with lowercase is private. Nice and easy. So that applies to variables and function names. And then this is how we declare a variable. This is actually a longer way of declaring a variable. Each variable in Go is type. Go is strongly typed, and you can type juggle. You can change the type later on. And there is also a shorthand for declaring variables, because Go can actually work out the type of the variable based on the value that you assign to it. So in this case, we declare a variable called words, and it's a string, an array of 2 strings, me and t. And Go knows now that the type of words is an array of 2. 2 strings, I should say. So say we want to print out 5 of those sentences with a random word each time. So we have a for loop here, at the bottom here. Notice there's no brackets underneath it, around it. So that's true for and if statements in Go. So that's unlike PHP. And there are also no semicolons at the end of lines. So there's a bit less visual debt, which some people are really precious about. So let's run our program. You can just do go run and the file name. So we get our 5 sentences as expected. So go run will take your code and run it, but it won't actually create the binary for you to run later on or ship it somewhere. So if you wanted to create the binary, there are 2 tools called go build and go install. There's a subtle difference between them, but it's not really important right here. So if you do go build Lionel Go, and then you list the files that you now have this red thing, which is the binary, and you just run it here like any other binary. So this is on Linux, or on a Mac, so you just do / and the binary, and you get the same result. So I mentioned using Go build and Go run and Go FMT, and these are just some of the many, many, many tools that you get with Go out of the box. So this is where I think Go really wins over a lot of the other languages, because the setup is so easy. Like, you basically need everything you need to develop and test and even performance test your app out of the box, and that's just a huge bonus. Because in PHP, if you want to do unit testing, you have to install PHP unit separately. And if you want to debug or profile your application, you need to install Xdebug separately. And you have to set it up for every project, and it gets quite tedious over time, and we've all been there. So it can just be a faff. So having this come out of the box with the language that you only need to install once is a huge bonus, and it's a huge time saver. So with Go, you get a formatter, a linter, unit and performance testing, code coverage, documentation generation, different compilers, just a whole bunch more, including like a race detector as well. And once you have it set up on your system, like Go installation is really easy. Just install Go, and it comes with all of this. And you're good to go for every single project. So when I first discovered this, I was like, yeah, like that's really good. That's really promising. So one of the things that can trip people up at the beginning is this idea that all your Go code lives in the same space, in the same directory on your disk. So that's the official way of developing Go, and that's the thing called GoPath, which you might have seen people ranting about on the internet. So with PHP, you can put your files anywhere in your disk. As long as your server is pointed at it, they can just be anywhere. And with Go, you have this special environment variable called GoPath that you only set up once when you set up Go on your system. And you just point it at whatever directory on your disk where you want all your Go code to live in. And inside, you will have 3 directories called pkg, bin, and src. And that's just kind of expected by Go to be there. It's going to be created by Go. So src, which is this one here, is where your Go code lives. And then the sort of idiomatic way of organizing your projects is to, because obviously every project is going to have a unique path to it and a unique name. So the solution for this is to use vendoring. So usually people use the place that you store your code. So if you have your code on GitLab or GitHub, then you just do github.com or gitlab.com/the username, which GitHub or GitLab will force that to be unique. And then you do the project name. So that way you avoid the clashes in the project names. And this is kind of like the simplest dependency manager on earth. Because Go initially didn't ship with a dependency manager, because the assumption was that if Go knows where all your code lives, if you pull down the library, and that the libraries will go into the pkg directory, then Go knows exactly where to find it. So if you then import that library in your code, Go can automatically link that binary into your code. So that's like the simplest dependency management on earth. It turned out to not be enough for real life projects, but that's kind of the idea behind why they've done this. So some people like it, some people hate it. I personally don't mind. You get used to this pretty quickly. And right now, my code has never been this organized. When I was doing PHP, it was just all over the place, and I could never find it again. So that's an upside for me. So what kind of apps you can build with Go? I tend to think of Go as a box of Lego bricks that you were just given. So you can build all sorts of cool things with it, but you've kind of got to do the work of working out how you're going to build it yourself. PHP is kind of more like the ready-made sets that you're a little bit more, a lot of the thinking has been done for you up front, and you're kind of maybe a little bit more limited as to what you can build with them, but you don't have to do all the thinking yourself. So both languages are great for web apps and for APIs. You can use PHP or Go to write command line apps, or even bash scripts. And I think PHP excels at the web level. It's just so fast to make a website in PHP. Whereas in Go, you can build a lot of the lower level infrastructure type things as well. So you can build proxies, reverse proxies, load balancers, servers, all sorts of things like that. And actually, I've yesterday discovered a project. It's a server that serves PHP in Go, and it claims to be faster than Nginx and FPM. So I haven't looked into that yet, but that's a bold claim. So you can do all sorts of infrastructure components as well. Anything that pretty much doesn't need a UI and needs to be fast, Go is a good candidate. So let's move on to the reasons why so many people start looking at Go, and that is the concurrency. Before we dive in, let me just quickly mention something that I wasn't even aware of before I started doing Go. Because as a PHP dev, you rarely, or like never, like in my case, have to deal with concurrency. You don't really come across it in PHP projects. So you can use a PHP extension called pthreads in productions, and there are frameworks like React PHP and AMP. So I haven't used any of them, so I don't really know how good they are, but I haven't like heard a lot about concurrency in the PHP world. And most PHP implementations just tend to be single thread based. So it's just less common to come across it. Go, on the other hand, has been designed with concurrency in mind, and it has been optimized for that as well, so it kind of outright promotes it to you as a developer. With PHP, it can be added on, so while it can probably work well, it will be slower just because you are using a framework. You're not using something that is built into the language like natively. So it wasn't until I started doing Go that I didn't have to think about what is concurrency and what does it mean for my program to run concurrently, or to run in parallel, and is concurrency and parallel the same things or not? Turns out it's not. So concurrency is when at least two threads have the potential to make progress at the same time, in theory. And parallelism is when at least two threads are executing simultaneously. So you can have a concurrent design in your program. Your program can be designed in a concurrent way, where in theory, you can have multiple threads making progress at the same time. But unless they are actually physically running at the same time, the design is concurrent, but it's not parallel. So parallel is more about the literally running at the same time. It kind of depends on, most of the time, it just depends on what hardware you're running your app on. If you only have one core, you can have a concurrent design, and your operating system will likely use something called virtual parallelism. So it will slice your single thread into like really short windows, and it will time slice them. So it will appear like multiple threads are running at the same time. But actually, if you like zoom down to the physical level, it's always one thing at a time, because then you have one core. If you have multiple cores, say 4, then you can, in theory, have 4 threads running at the same time. So that's actually actual parallelism, as well as concurrency. So just to show you a silly example, this is a slide taken from an excellent talk by Rob Pike, one of the Go creators, called Concurrency is Not Parallelism. So if you want to watch about 20 minutes on that, then I highly recommend it. So in this silly example, we have a bunch of gophers burning books, as they do. So we have 2 sets of 4 gophers, and each of the 4 gophers has a specific role. So one of them is loading the books, one of them is taking the books to the incinerator, one of them is loading the books and to burning them, and then the other one is taking the empty trolley back. So this is a concurrent design, because in theory, we can have all 4 gophers running around and doing their jobs at the same time. So assuming a world that is like where they're all perfectly synchronized and they don't wait on each other, then in theory, that can run concurrently just fine. And moreover, if you can multiply this sort of in many ways. So if you just take the set of 4 gophers and add another an identical set of 4s, then you can just scale up your program that way. So now we have 8 gophers. But if only one of those 4 or 8 gophers was moving, then the design is still concurrent, but it's not actually parallel, because only one of them is running around at any one time. So we talk about concurrency in Go because it's the more generalized form of parallelism, and it doesn't sort of worry about the implementation, the technical details of how you actually run it. So it's worth keeping in mind that a concurrent design does not always guarantee parallelism. Like I said, it mostly depends on like what kind of hardware you're running on, how many cores you have. So I thought it was just interesting and worth mentioning because it's just not one of the things that you become aware of if you're doing PHP. So one of the most appealing things about Go is how easy it makes to write, writing concurrent programs. So basically, it boils down to 3 words: the Go keyword, Go routines, and channels. So a Go routine is not exactly a separate thread. It's officially called like a separate lightweight thread of execution, and it's mapped onto the OS threads, but it's not a one-to-one mapping. And all Go routines are managed by the Go runtime for you, so you don't actually have to do it yourself. Go routines all run in the same address space, so they all access a shared memory. So you need to be a bit more careful about synchronizing access to that. So that's where all the mutexes and all of that stuff comes in. So it's just like with any concurrent program. And here's how we create a Go routine. We just put the Go keyword in front of whatever function you want to call, and it's that simple. So that function, the my function, is now going to be executed in a separate thread of execution. So here's a simple example of using Go routines. Say we want to print out hello world, but we want hello to be printed out, say, 5 times by the main thread, and we want world to be printed out also 5 times, but by a separate Go routine. So we define a function called say, dead simple. It just takes in the word, and it will print it out 5 times in the loop. And then in the main function, we call the say function twice, once for hello, once for world. But on the first line, we put the go keyword in front of the function call, and that will make Go execute that function in a separate Go routine right away. So this is non-blocking as well. So as soon as that line gets executed, the main thread will just move on to the next line and kick off say with hello. It's not blocking. It's not going to wait. So in theory, the say function will be executed at the same time for the 2 words. So here's the output. We get both words printed out in a random order by each one of the Go routines, so that's as expected. And if you run it multiple times, you get a slightly different output every time, because the order in which they will get printed, it's completely random. So without any deliberate synchronization put in place, it will be completely random because they're all running concurrently. And you might notice here that actually in the second column, hello was printed out last. Hello was being printed out by the Go routine. So that means that the main Go routine has terminated already while the other Go routine was still running, and it got there last. So the main Go routine is not going to wait for the other Go routines to finish. It will exit. And that's not really ideal, because that's how you end up with zombie Go routines. And at that point, like kill -9 is probably your best option. So it's not great to end up in that situation. So it's good to put some kind of control or synchronization in there. And to do that, one of the ways to do that is to use something called the wait groups. So just to make sure that we don't exit the main Go routine until the other Go routines are done. So here we declare one at the top, and we add 1 for the one Go routine that we're about to kick off. So in general, you just add 1 for every Go routine that you kick off. It's kind of like a Go routine counter, essentially. So then we kick off a function, an anonymous function. So Go also supports closures. And in there, we use the special defer keyword to make sure that we call done on the wait group before we exit from that function. So defer is it behaves like finally, essentially. It's just guaranteed to be executed at the end of your function, no matter what happens in between. It's really handy for making sure you don't forget about things like closing your file handles. So you can put a defer statement right after you've opened the file, and that just makes sure that you don't forget to do it. And also, it means that Go will take care of that for you at the end of the function. You can also release mutexes using defers, or you can tell the wait group that you're done. And then we call say in the usual way. So then we also called say hello from the main Go routine afterwards, and then we wait. So we called wait on the wait group, and that means that the main Go routine will just wait on this line until the wait group has received as many dones as it had the ones added in. So if it had 1 Go routine added, it will need to receive 1 done. And then as soon as it gets it, then the wait group will stop waiting, and then the main thread will resume. It will move on to the print line, print out done, and then exit. So that means that we make sure here that everything else will be done before we exit the main thread. So it kind of illustrates here that analyzing concurrent programs can be a little tricky, because some things may be deliberately happening at random, and some things will need to be carefully synchronized. Like I said, there are wait groups, there are mutexes for managing access to shared memory or shared space. Luckily, a lot of the native Go functionality is safe for concurrent use, so you don't really have to worry about it too much. It's pretty easy to use those constructs, so it's not as scary as it might look. And like I said before, Go even has a race detector built in to help you debug those cases a little bit better. So there is a slightly better way to manage synchronization in Go programs, and that is to use the channels. So you can think of channels as just pipes or queues, where you can put values into the queue or take values out of the queue. And if you share this queue or a channel between 2 Go routines, then you can send and receive messages between those 2 Go routines. So channels are first-class citizens in Go. They are typed, so each channel will have a type of the values that it can carry. And it can only be one type, and you can't change it afterwards. So channels can also be bidirectional, so you can send or receive, or they can be only one directional, so you can only send or only receive on a channel. By default, sending or receiving data on a channel is a blocking operation. That means that if a Go routine is waiting to receive something on the channel, it will wait on that line until it gets the value. And it's the same with trying to send a value. It will wait until it can send a value on the channel before moving on. So this allows you to synchronize Go routines without really neatly, without using the explicit locks or wait groups or mutexes or some kind of crazy complicated conditionals. So we declare channels just like we declare variables in Go. So here's a variable called messenger, which is a channel of strings. Before I use this channel, I need to actually create it. So there is a make word in Go. So we use that to actually make that channel. And that make command also takes an optional second parameter, which is the size of the buffer for a channel. So like I said, by default, the channel size is 1, so you can send one value or receive one value, and until you can't send the next one in until the first one has been taken out of the channel. But if you use the second argument, say 3 elements or something, then that means that the channel will have a buffer of 3, so you can send 3 values into it before you get stuck waiting until you say send more. And it's the same with receiving. So here we just use a simple unbuffered channel. And if you want to send some data on the channel, you use the special arrow keyword in Go. So you sort of point it at the channel, and you put the value that you want to send on the right. And if you want to receive data on the channel, you kind of do the reverse. So you can also assign it to a variable. So here we assign it to message. So you point the data away from the arrow away from the channel. So in general, when you're reading Go code, the data kind of flows in the direction of the arrow. That's like a rule of thumb. So this is how you might implement a typical pattern used in concurrent programs called the worker pool. So that means a worker pool is essentially where a pattern where instead of having one thread of execution deal with tasks in a synchronous way, in a sequential way, then you can create multiple worker Go routines and have all of them waiting for incoming tasks, and then just process them at the same time concurrently. So that means that you can speed things up. So say if you have 5 workers, you can, in theory, process tasks 5 times faster, or like 3 times faster if you have 3. So you can just decide how many workers you want to spin up. So here at the top, we create a channel of tasks. So we just assume that task is some kind of struct describing a task. And we call it jobs. And then at the bottom, we use the special for range construct to loop over some kind of slice on the array of work to be done. And then we send each of the tasks onto the jobs channel. So that's kind of how we load it in. And then we need to decide how many workers you want to create. So that will be defined in the limit variable. And so in that function, so we will create for every, until we hit the limit that we've decided on, we will kick off a function, again as a closure, with the Go keyword. And then inside that function, we'll use the for range construct again to listen and range over the incoming tasks coming on the jobs channel. So this here means that as soon as something becomes available on the jobs channel, it will be taken out of that channel, assigned into task, and then here you will just do whatever you wanted to do with that task. So all of those Go routines, all of those workers will listen on the same jobs channel here. So it means that you can't predict which one of the Go routines will pick up which task. It will be completely random. But in most cases, you're actually OK with that. You don't really care. So hopefully that just illustrates that by using concurrent designs like this, you can really speed things up. And like we had a case at work where we had a PHP app processing incoming emails, and it was like an ugly 4,000 line long PHP script that would like take an email out of the pop mailbox, process it, take the next one, takes the next one, and it kind of just got to the point where it was running with a backlog of 5,000 emails. And then we rewrote that PHP app in Go, and I think we put in 5 workers just to pick up the emails as soon as they become available. And like it's never been an issue since then. It just processes them right away. And emails is one example where, because each email is independent and you don't really care about the order in which you process them, like the worker pool is a perfect candidate here. So for me, just the ease of picking it up and learning concurrent designs and even event-driven designs in Go, it was one of the reasons why I really enjoyed learning it so much. You can obviously try out the frameworks in PHP, but I think just using a language that outright promotes it to you and supports you along the way, it just makes it a bit easier to play around with and pick it up. So my intention wasn't really to tell you that Go is better than PHP or that PHP is better than Go. They are just different. And you should think about what you want to build first and what's the problem that you're dealing with and which language will help you solve that problem in the best way, in the most efficient way, the easiest way, the quickest way, or the most elegant way. So in general, in this day and age, we need to be getting smarter as programmers. And we need to find ways to optimize our programs and our processing with the ever-increasing loads these days. And so this can really take you this step further. So exploring other languages which allow you to do concurrency and discovering all the different patterns and event-driven design, it really helps you solve those problems. So I think as developers, this will become more and more relevant as the loads just keep increasing. So obviously, I ended up comparing the two languages quite a lot as I was going along. So here are some of my favorites about each. I still think that PHP, at least for me, is great at just bashing something out quickly, especially if it's not a concurrent thing that I'm writing. If it's just simple and sequential, I'll probably just still use PHP to just bash it out quickly, because I can just do it without thinking too much. I like that PHP has a lot of mature and well-established frameworks and libraries to choose from, so things like Composer for dependency management, or Slim, or Laravel if you want a framework, and that kind of thing. PHP is pretty widespread. It's been around for ages, so there's lots of help online, lots of tutorials, lots of docs. And PHP 7 really is a huge step forward. Like, it really brings PHP back in the game. So yeah, people who still think of PHP in terms of 5.4, 5.3, or 5.6, I keep saying, just check out PHP 7 and then come and talk to me. So there are also quite a few things that I liked in Go as well. I love that it's strongly typed. And I'm really happy that it's coming to 7.4 as well in PHP. To me, it just feels safer and less prone to errors to not type juggle. And you just avoid surprises along the way if you don't do it. I really like what's called the idiomatic Go. So it's basically just a way of thinking which promotes simplicity and just keeping things simple as they can be, but not simplistic. And I love the error checking policy in Go, and I'll come back to that in a minute. I love that Go allows you to return multiple values. So you can return multiple values from functions in Go. And that just comes in handy so many times. I think it's a more natural way to write functions. And you don't have to do arrays with fields in them or DTO objects just to return multiple values in Go. I love the tooling, as I already mentioned. I like how easy it is to set up Go and just get going with it and just have it running. I love the built-in concurrency. I'm really impressed by the speed. It's really, really fast, and how much faster your programs can be if you rewrite them in Go. And I really like the wide range of applications that Go gives you as well. Some of my not-so-favorite things about each, things that I think maybe could be better. So PHP, as opposed to Go, it feels more inconsistent, and that's kind of not really surprising because PHP has been around for a lot longer. Go is a fairly new language, so obviously they have less of that sort of legacy in there. And we probably all know the Fractal of Bad Design article that lists hundreds of inconsistencies in PHP. PHP kind of lets you do stupid things and get away with it a lot of the times, which is not something that I really like. Stuff like type juggling or leaving around dead code. Go doesn't let you leave dead code around. If you're declaring a variable and not using it, it will flag it to you and it will not compile until you remove it, which drives you nuts sometimes while you're doing your code. But at the same time, it's just so good. You never have to deal with that problem. And that's possible because Go is compiled. So obviously you can before you run it, it can do all the static checks and figure out what's used, what's not. With PHP, you can't really do this when you're interpreting the code on the fly. PHP, to me now, it feels a bit more verbose with the extra brackets around 4 or the semicolons. It's not really a massive problem, but it does feel a bit more verbose these days. And I really, really wish for the multiple return values in PHP sometimes, or quite a lot of the times. Go, on the other hand, it sometimes feels a bit lacking in terms of mature, well-established frameworks that you can use. So it's probably less of a case this year, I think, for me. But last year, I think I tried 3 different logging libraries, and each one of them was just almost good enough, but nothing really quite felt V1 ready. It was all 0.9 version. So they all did things right, but none of them had everything that I needed. So there were a lot of solutions that were kind of not exactly the full-blown solution that you would hope for. And quite a lot of the time, because Go it feels a bit more bare bones to you because like PHP kind of has a lot of handy shortcut functions that you can use for string manipulations and that kind of thing. Whereas Go doesn't have that quite a lot of the times, and the argument there was it's actually faster for you to write a for loop to loop over some string and do whatever you want with it than to call another function. So that's why that they've kind of tried to keep the standard library fairly small, and if something is just done quicker using a nested for loop or something, then they will be like, do that instead. But it is sometimes it feels a bit tedious, and you're like, oh, do I really have to write it myself? In PHP, I could just use this function, and it would just be done with it for me. So one of the sort of final things is the dependency management, which is a solved problem in every single language except for Go. It's less true these days because Go is about to get a native dependency manager. I think it's rumored to ship in 1.12, so it's already in beta in 1.11. And Go introduces the concept of modules, which is, it sounds really weird to start with because it's very different to like what Composer does. And I think it's a mixture between what Node like NPM does and what Composer does, and some new ideas from the Go team. So we'll see how it goes, but it is rumored to be shipped, but it's just a shame that we had to wait till 1.12 to actually get a proper dependency manager. There were a lot of open source dependency managers written, like kind of Composer style, and they've become like the standard to use. But now you kind of have to switch your project back to the official way of doing things. So an interesting observation for me was noticing what I started doing differently in PHP after doing Go for some time. So I think as a result, I'm definitely more mindful of keeping things simple and as simple as possible and as clean as possible, even if the language isn't forcing me to. Like PHP doesn't force you to not type juggle. So I definitely became more strict with types, even before we had the strict types in PHP. Never really liked it, so I'm just declaring strict types in PHP 7 now. I tend to also use shorter and more sensible names. If I have a class that sits in the controller's namespace, do I really need to call it home page controller? Maybe there's a slightly simpler way. I certainly tend to avoid the enterprise style naming. This is my favorite example from another talk by Rob called Public Static Void, which is, yeah, that is my favorite bit, because, yeah. So short names. Error handling. Imagine we're validating a name. The thing on the left is what I used to do quite often before I started doing Go in PHP. So I can't really easily tell you what's going on the left. Like I'll have to like look at it and figure out in my head and go if, else, oh, then return. The code on the right, it does exactly the same thing, but it's just so much easier to understand right away. The difference is that in Go, you tend to handle errors as soon as they happen. So usually the last value returned in Go will be the error. And if the error is not empty, if it's not nil, then you handle that first and you just discard everything else. So that's like a Go mentality that you get used to pretty quickly, that you always handle the errors first. So it's kind of like a failed fast approach. So you basically just, that approach allows you to not run into the risk of doing something that you didn't mean to do if there was an error, but you did it because you only end up checking the error like somewhere here at the bottom. There are obviously exceptions to this rule, but in general, I now prefer the fail fast approach in PHP. And I think it's just a good practice in any language. And Go just made me apply it more. And it also gives you the benefit of just making your code a lot more understandable. So there's this concept of the line of sight here. And the thing on the left, like you kind of have 3 lines of sight. So you have to nest your eyes in your brain like 3 levels deep to understand like this condition. And then you have to backtrace and understand the full thing. Whereas the thing on the left only has sort of, if you didn't count the first one, it only has 1 indent, so 1 line of sight. And it just means that you can like scan through the code and read it top to bottom really, really easily. So that's like another side benefit. Using interfaces. If you design your domain well, you can leverage the power of interfaces, and then you can venture into things like DDD and hexagonal architecture. And that basically means that your code is much easier to change, and you just keep the changes local. So this is actually, I got into DDD and hex architecture through Go because it really promotes the use of interfaces. And Go has implicit interfaces. So instead of thinking about interfaces that some kind of class is an implementation of interface A, In Go, you more focus on the properties that a given struct might have. So it's more of a, if something has the methods defined in an interface, then it is implementing that interface. And Go will work out what interfaces your structs are implementing for you behind the scenes, so you don't actually explicitly declare it. So if you declared an interface for a shape, for example, which has an area function, then you can have a circle struct. So you just declare it here, and then you define an area function on that struct. Then at this point, Go knows that your circle is implementing the shape interface, and you don't declare it anywhere. It just works it out behind the scenes. So it makes refactoring a lot easier because you don't have to update your references. It will just work it out for you. In PHP, of course, you have to do it explicitly and change it if you decide to move things around. So I think learning Go has definitely made me a better PHP programmer. Knowing more than one programming language just really gives you more than one worldview. And you can share ideas across languages. You can port them back if you want to. It goes without saying you're more employable. These days, people usually look for more than one language that you know. And it just feels great to have another tool under your belt. So I really encourage you to go out and learn whatever language you wanted to learn next. It doesn't have to be Go. If you did want to try out Go, here are some links from me, some recommendations for where to start. And the golang.org website, it really has it all. It has the main site, it has a playground where you can actually try out Go in your browser without installing anything. There's a tour of Go, which is a nice introduction. Go by example is also a really nice introduction to Go. Blog.golang.org, it really provides a lot of sort of background information for why things have been done a certain way, or a really in-depth dive into how arrays work in Go, or that kind of, or how the Go routines are mapped to OS threads, and all of the details, but also some kind of lighter entry-level blog posts. And then some of my favorite talks, two of the ones that, the first one I already mentioned, it's the concurrency is not parallelism. And there was a second one by Rob, which is called Simplicity is Complicated, where he talks about it's actually quite hard to arrive at a simple design. If you're into containers, then there's an excellent live demo done by Liz Rice on how she implements a simple Docker-like container in Go. That was at Golang UK, I think, 2 years ago. And then this year, she started doing another live demo talk, which is writing a debugger from scratch in Go. So if you're curious, then the last two bottom links. I will tweet out the slides. I think I've already tweeted them out, so you can go and have a look. My Twitter handle, if you have any questions, or if you have if you want some further information, then I'm happy to help. One last thing, this talk just really wouldn't be complete without mentioning the communities that we have. So I think both communities are great. And this talk is just proof that you don't have to limit yourself to one community. The PHP community rocks, and we have so many great conferences and meetups. I think this is PHP Bulgaria, and I just love James in the background. It's just classic. Go is quickly catching up, though. It's only 6 years old, but there are so many conferences now for Go. The first Go conference, they're called GopherCons. They tend to be called GopherCons. The first one was in Denver 5 years ago. And since then, we've had Go conferences pop up literally everywhere. So there is GopherCon UK, which is usually in August in London, GopherCon EU, there is .go in Paris, there is GopherCon Brazil, GopherCon India, Gotham Go in New York City, there's a Gopherpalooza in San Francisco this year. So if you're curious, check out a conference or a meetup near you. There's a good chance there actually will be one. So with that, I hope you enjoyed the rest of the conference. Thanks for coming. Slides are up online. There's a link here as well. I tweeted them at the ScotlandPHP hashtag. If you have any feedback, then this is a joined-in QR code. And I don't know if we have any time for questions, but I will be at the social. I will be around, so just grab me if you want to have a chat.